This is 2007 Part C. Hydrofluoric acid reacts with sodium hydroxide according to the reaction represented below. We have an HF plus an OH minus that came from your NaOH, and that's going to yield water plus your fluoride ion. Now this looks kind of weird because the sodium's not included, but that's just because sodium ion is a spectator. Okay, a volume of 15 milliliters of 0.40 molar NaOH is added to 25 milliliters of 0.40 molar hydrofluoric acid solution. Assume that the volumes are additive. This is a really important sentence, so I'm going to think to myself, total volume is going to be equal to, 15 milliliters plus 25 milliliters, which gives me a 40 milliliters in the end. My goal now is to calculate the number of moles of HF remaining in the solution. So basically, I have a titration happening here. For all titration problems, you're going to want to first, number one, do a stoichiometry. And you're probably going to have a limiting reactant, considering it's a 1-to-1 ratio in our chemical equation, and you're adding 15 milliliters of 0.4 and 25 milliliters of 0.4. So one of these things is going to run out first. That's going to help us. Later in this part of the question, you're going to want to do an ice table. I'm pretty sure we're going to have to leave that until parts D or E, so we'll worry about that later. Okay, so let's make a fake ice table with moles. I'm going to put a thick line right where the arrow is usually at. We're only going to put moles in this fake ice table, where the I stands for initial moles, the C stands for your change in moles, and the E stands for ending point. So when your titration is sort of done. I'm going to ignore water because any change in concentration of water is going to be unimportant in an aqueous solution. And yeah. So let's add these little bars. Okay, now the first step is to fill in my initial moles of my HF. So I'm going to take my 25 milliliters, and I'm going to realize that that is the same thing as 0.025 liters, which is much more helpful to us. We're going to take these liters, which is the amount of solution, and I'm going to multiply that times the concentration of my HF, which is in molarity, which is the same thing as moles per liter. This will get me my moles of HF that I'm starting with. So just put that into a calculator, and you end up with 0.01. Well, I guess you'd have to add another 0 in there. We'll do that in the table. So 0.010 moles of HF for starting. Then we do the same thing for the hydroxide. We're starting with 15 milliliters, which is the same thing as 0.015 liters of that hydroxide, and I'll take that amount of liters and I'll multiply it times the concentration, which is moles per liter because it's molarity, and that number is going to equal 0.006. Again, these are going to be moles of hydroxide. We'll stick that amount of moles into our fake ice table, And now we're going to look at these two species. If this reaction goes to completion, which is what that single arrow indicates, our hydroxide is going to run out first. We have a 1-to-1 ratio, and it's a smaller amount. So I'm going to subtract 0.006 minus 0.006. My hydroxides are totally gone at the end, and I'm going to have 0.004 moles left of hydrofluoric acid. So we're going to have to write that like this. Moles HF left equals 0.004. Then you'd box that answer and you'd be done with part C.